So when we talk about atoms bonding together, atoms can bond together to create molecules two separate ways. Okay, we're really only going to talk about one of those two, and it's not even really an ST topic. Okay, we're going to talk about ionic bonding because we have to talk about something called ions. But and this whole chapter deals with molecules. And a molecule is when two or more atoms bind together. Now notice how I didn't say two or more different kinds of atoms. Because you can have some molecules of atoms of the same element. Okay, in nature there are a variety of atoms on the periodic table that are not stable all by themselves. That's why you often see oxygen described as O2, because in its stable form, oxygen needs two oxygen atoms bound together. Hydrogen is like that as well. So is, I believe, iodine is like that, and I want to say nitrogen is like that. Okay? Another one that's interesting is sulfur. Sulfur is, I believe, in group 6 maybe, group 5 or 6. You can check your periodic table, I don't remember. But sulfur in its natural state likes to be with 8 other sulfur atoms. And that is a stable unit or molecule of sulfur. And then we've got other molecules that have different kinds of atoms bound together. The classic one, okay, where it's a 1-to-1 ratio, is table salt, sodium chloride. One atom of Na bonds to one atom of Cl. Okay, and by bonding, they make a very stable molecule. So this is a 1-to-1 ratio. We could have, a variety of ratios here. Okay, the most common molecule on the planet, H2O. Right? What is that? Water. That we know that is water, but that's really two hydrogen atoms bound to an oxygen atom. Okay? And by binding like that, they're either, one of those elements is either fully giving away its electrons or they're sharing them. And when they split up, they either take them back if they're sharing, but if they've given them away, they can never take them back. So if we look at the elements of the periodic table on period 2, we've got about 8 elements, and what we're going to do is we're going to draw the Lewis structures of each of these elements. So lithium is in group 1. How many valence electrons? 1. Beryllium is in group 2. Boron? 3. Carbon?
4.
Nitrogen?
5.
Oxygen?
6.
Fluorine? And neon.
8.
So when we look at these, we know that neon is also called a noble gas or an inert gas. It's called that because its valence shell is full. It doesn't need anything else, which is why you never see those actual those noble gases or inert gases. You never see them bonding with anything else. They don't need to bond with anything else to be stable. They're already extremely stable. But every other one of these groups, from 1 through to 7, is not necessary. The atom is neutral. Okay, an atom is neutral, which means it has the same number of protons as electrons, right? So in terms of its charge, it's neutral. But it's not necessarily stable if it's got an open amount of electrons on its outermost shell. And what I mean by that is, let's draw something like sodium. Okay, let's draw an atom of sodium. Sodium has an atomic number of 11, I believe. So 11 plus, we're not going to draw any neutrons or protons. Right, there's its nucleus. In its first shell, it has how many electrons? Okay, so I'm just going to draw its 3 shells because I know it's in the third period. So we're going to put in these electrons and then we're going to talk about it. So if we look at an atom of sodium, it is totally, it's neutral. It's got the same number of protons as it does electrons. It's got 11 protons, it's got 11 neutrons. It is neutral. It does not carry a charge. That is not the same thing as saying that it's stable. Okay? It is not. Because it's got that 1 electron on its outermost shell. How many electrons does it want on its outermost shell? It wants 8. It's got 1. So, is this atom more likely to take 7 electrons from other places or give away its 1? It's going to give away its 1. And see what happens. See what happens when it gives away its 1. When we get rid of that 1 electron here, okay, when we get rid of this guy, okay, it now, this whole outer shell doesn't exist anymore because there's nothing there. We go back to the shell before it, it's a full shell of 8. So that is stable. But in giving away its electron, it had to bond to something. Right? So let's say it bonds to chlorine. We know this is table salt. It's going to fill chlorine's outermost shell with its 1 electron. It's going to lose an electron. They're going to bond together. They're going to be nice and neutral and happy. Okay, that molecule is going to be stable. But sometimes when these little bondings happen and when something gives an electron to something else, if that substance breaks up, sodium will never get its electron back. So is it now a neutral atom if it doesn't have the same number of protons as electrons? It is now a positively charged atom, which no longer makes it an atom, it makes it an ion. Okay, so we are going to talk about all of this in different sections in this chapter. But if we look at all of these, we can easily see whether an element is more apt to take or give away electrons. How many extra electrons on that last shell does lithium have? How many electrons does it have on its outermost shell? So it's got 1 extra. Is it going to take 7 or give away its 1? Okay, so it's got 1 extra. It's going to give away. What about beryllium? It's got 2 extras. It's going to give those 2 away rather than take 6. So it's got 2 extras and it's going to be a giver. Okay? What about boron? It's going to give its 3 extras. Now, here's where it gets interesting. Because carbon has 4. It's halfway there. So in some instances, elements that are in that group number 14 that have 4 valence electrons, sometimes they're going to be givers and sometimes they're going to be takers. Okay? So it has 4 extra electrons. It's going to give or take, depending on the situation. What about nitrogen? How many does it have? It has 5, therefore it's missing 3. It needs 3. Okay? So it's going to be a taker. What about oxygen? It is missing 2. It is going to take 2. What about fluorine? It is missing 1. It is going to take 1. And what about neon? It's missing none. It neither gives nor takes. It ignores everyone. Okay? It's a loner. So when we look at this, all right, it's kind of interesting because it seems to almost form a pedestal where it comes up, it goes down, it goes down. It goes up. They have extra, they have more extra, they have more extra, they have the most extra, they need the most, they need a little bit less, they need the least. Do you see that? So, when we start talking about givers and takers, okay, this is going to become very important as we move on to the next topic, which is the idea of an ion. Okay, an ion an ion's going to actually be a little bit familiar to our positive and negative charges of atoms. Okay, when we talked about how many protons and how many electrons an atom had, and whether it had a positive charge or a negative charge, we were talking about ions. So now all we're doing is giving a name to this.